So, hi everyone. So, I will start with like about project and what is the work and what we're going to do. So, this training going to complete like in team. We have one team size, right? In real time, we have 8 to 12 members in the team. So, manager, okay, admin, developer, analyst, okay, and architect, okay, other users. So we're going to do what? So every work we're going to do. Okay, every work. So we're going to take 8 members of team. Okay, one is like manager, architect, and developer, analyst. There are in real time we're going to have 3 4 developers in the project. Minimum 2 developers going to be there. So what they are going to do, everything, entire project experience and work experience, everything going to get it. So what I'm going to teach like Snowflake plus AWS 3 services and DBT and ADF bulb storage plus SQL. In between, when I'm teaching Snowflake, we're going to cover SQL concept also. SQL means nothing but like here we need to call Snow SQL. Okay, so it won't support indexes in the Snowflake. Okay, so what is the project we're going to do? Healthcare domain. So completely, so real time, how we going to have the tables and data. So in a single column, in single table, we're going to have number of columns, right? More than 20 like that. So we're going to have everything. So healthcare domain, healthcare domain. So this is like a data migration project. Data migration part. So what is migration? Migration means we have some scripts or some data in Oracle or SQL Server. So those data we need to move to Snowflake here. So in between what we are doing, and after moving data, what we're going to do. So finally, what is the output? Okay, result. This we're going to discuss everything. So first we will start with client. So think the client having some data, and there will be insurance people. Okay, so they have some claims data. Okay, there and we have patients patients details, patient's details and doctor details. Okay, so we have different, okay, completely data set we're going to take. So there are multiple tables, not 3 4 or 10. So more than 10 tables, like 20 tables we're going to take. Okay, so that you're going to see in the classes. Okay, so client, okay, client is the requirement first. Okay, so how the color is going to be? Client, you going to give the requirement to the manager. The manager going to talk with the client. Like I have like patient details, incident details. So who have not claimed or who have claimed again and again any duplicates. Okay, so I need output for this one. Okay, they will ask like that the requirement. So after that, architect will come. So this manager going to discuss with architect. So architect, what he going to do? So he will check the files. What are the how many tables are there? So what we going to approach? Like we have star schema and Snowflake schema, right? Snowflake schema. So Snowflake schema. Okay, starting classes going to be theory. Okay, if you know theory, then only we can do the practical. So that is best way of learning. Theory, practical, real-time scenarios. This is my way of, okay, training, giving teaching. Okay, theory, practical, real-time scenarios. Okay, so he going to think architect. Okay, so what you will say? So which approach into follow? Star schema, Snowflake schema, or initially we go with in we have different environments, different layers. So initially we go with usually Snowflake schema. After in the final layer, curator layer, we going with the star schema. It going to be star schema. Why? Because of, so when we are sharing data with the BI tools, it going to be easy. Okay, easy. Okay, to share, give the output. Okay, so initially we go with Snowflake schema. After that we go with start schema in the final layer or curator layer or reporting layer. Okay, we have different names. Okay, so usually what are the layers we have? So one is like, so raw layer, and second one is like, okay, so transformation layer we can call it, or we're going to call staging layer. So staging layer. Then third one is curated curated layer. Okay, curated layer. So raw layer, like, so when the client or different insurance people, okay, they from Oracle or SQL Server, okay, so from different sources we going to get the data. So this data we need to handle. Okay, so first we're going to load data into the raw layer. So it's going to be completely like duplicate values, null values, and unnecessary spaces. Okay, some data type issues, okay, everything we have in this layer, this data. So it's going to be, it is data like denormalized. So denormalized data. Okay, so I will explain what is a denormalized everything. If we don't know what is a denormalized, we will discuss in the, when we are discussing about star schema, Snowflake schema. Okay, so raw layer, this data, these tables are denormalized completely. So after that we're going to normalize the data. So the architect is going to design, so star schema or Snowflake schema. First we go with Snowflake schema. So depends on data, what are the types of data we are receiving and what we need to do with it. Okay, so denormalize data. So after that, in staging we have in the normalized data, so without duplicate, so no duplicates here. Okay, so no duplicates and no null values. Okay, and it's going to be a unique data, a unique data. So with the normalized tables. Okay, normalized in this layer, staging layer. Okay, so after that we do some transformations, then we move to like curated layer. Curated layer is going to be fact and dimension table. So these tables directly we can use to for report. So usually what is the process? Okay, so Oracle to, there will be ETLT. Okay, ETLT, what they will do, okay, they will push data into S3 bucket, okay, using Informatica, some other tools. So they're going to push data into S3 bucket or Azure Bulb Storage or GCP. Okay, so it will S3. So hereafter our process will be start. Okay, so we need to know about some services about S3. Okay, like what is the bucket and what is the role and ARN, what is the SQL simple cube service we need to know. Okay, so this, from that point, as a Snowflake developer, our process will be start. So we need to load this data into Snowflake. So usually before DBT, after loading data into Snowflake, we're going to do some transformations. Okay, from the curated layer, we're going to create like fact and dimension tables. Then we're going to share with directly reporting team, like BI tools. We're going to share that. This is the process. So now what we are doing, so we presently we are working with DBT, right? So Snowflake 2, after that DBT. Then after that, again the data will come to the Snowflake. You going to reflect again to BI tools like Power BI tab. So this is completely like your workflow, Oracle to ETL team using some Informatica, and they'll push data and S3 bucket. After that, as a Snowflake developer, our work will start. So we need to load these data into Snowflake. Then we do some like loading. We will connect with the DBT. When we load data into the raw layer, after that cleaning the data, we going to connect with the DBT. Then what we do, the transformation that going to reflect in the staging layer. So again, we, there are different layers in the DBT like staging, intermediate, hot layer. In DBT we have like staging, okay, so intermediate and mart layer. Here again mart layer also having like fact and dimensional table. It means, so what we have the data in curated layer, right? Here we have curated layer, what we have. So this data, okay, when we do transformation in the mat layer, it going to reflect in this the curated layer. So first staging means like raw data only. So when we receive raw, we have raw layer, right? What is the data we have in the raw layer? So same data we going to have clean data in the staging layer. After that, as per the business logic, we're going to apply some giants. Okay, different like if there is any sum of patients detail, like patients count, okay, doctors count, okay, which doctor have the more patients, like that details, it going to be reflected in this intermediate layer, that will be in the staging layer here. So after that, so we do final business logic. Here it going to be mart layer, it going to be reflected the curator layer. So this is the workflow. Okay, so when dbt snowflake to dbt transformation, then again snowflake it going, then after that, so be it. Okay, what we need to know here, we need to know about these features. Okay, dbt. Okay, then after that we need to know about SnowSQL. Suppose there is cloud provided Azure bulb storage, we need to know how to load data adf to Azure bulb storage to Snowflake. Then if we are using in the project GCP, we need to know how to load data. Okay, so these are AWS, okay, AWS and Azure and GCP. So these are cloud provided to the Snowflake. Snowflake. Here it is supporting the Snowflake 2014 and Azure 2018 and GCP 2019. So when we put in resume, so we have more concern. First, we need to give the preference Azure AWS services. Then after that, we need to Azure. Okay, we're going to put in the resume AWS and Azure. Okay, so as of now GCP are not putting the resume because of many, the requirement is most of the time, so we have AWS and Azure. Okay, so this one, so this one Snowflake to dbt and again Snowflake, then again reporting is Power BI team or tablet tool, they going to work. Okay, usually we going to have team number 8 to 12 members. Okay, manager, admin, architect, analyst, Snowflake developer, 3 4 members, 2 members, 3 members, depends on the work. Okay, like one dbt developer, one Snowflake developer, some both going to do dbt and Snowflake. Okay, so this is the workflow. Oracle to ETL team is 3 Snowflake DBT Snowflake again PA tools. Okay, so what we're going to do here, so we do the transition like raw layer to staging, staging layer to curator layer. So this data going to be used for the reporting. Okay, fact and dimension table. Here we're going to implement like star schema. So in before layers, what we're going to implement Snowflake schema, and we have like incremental data, right? What is incremental data? I will explain. So incremental or incremental process. So usually I have one table. So table like patients, patients table. So here I'm receiving today 100 records. 100 records I'm receiving. Okay. So I will create one patient table and I will load the data. Okay. So next day I'm going to receive some more 100 records. Okay. Plus any updated records in the last 100 records. Okay, this is number, just I'm explaining, not exactly. Maybe you're going to receive 150 cards. Okay, so you're going to receive, okay, 150 cards plus this first day what you have received. Again, you're going to receive same data, and this will be how you want to receive. Okay, these are the first one, first day new records. Second day, these are the new records and the old data you want to receive. Okay, so again, third day. So new records 160 and plus old records 100 plus again 150. Okay. So first day we create one table, the patients table. Okay. So what we're going to do, we're going to load these 100 records again next day 150 records, right? So we will suppose if you insert again this complete data, it's going to be duplicate data in this patient table. So if we insert, okay, it's going to be duplicate. So it duplicate data, right? Duplicate data. So what we will do in that scenario? So in that scenario, we will truncate this patient table and we will recreate most of the, we go with the truncate. So we will truncate this table. Again, we will load this data. Okay. So again, third day also same thing. We receiving again duplicate data with the new data. Again, we will truncate table and truncate and load. This is the usual process. We're going to truncate the tables and we're going to load the data. So if you go, so in real time, not we don't have 100 records, so we're going to have millions of rows. So it's going to affect, okay, it like cost and time it going to take the more cost, it's going to take the more time. Okay, if you go with the day by day, it's going to be billions of rows, right? So to avoid these, we have incremental data, incremental process. What is the incremental process? So here we're going to use streams concept. Okay? Streams and met statement, and we going to have the like task for scheduling we're going to use. Okay, these we're going to use here. So here we're going to create three tables: source and street table and target table here. So first of all, we're going to receive this data 100 records. Okay, we create patient table, we will load. So after that, we will create stream on this table. Then with in the merge, for the merge statement, we need to create one target table. Okay, this one. So first I will load 100 records. So next day I'm going to receive this all data, right? New data and 100 records. So it means uh, it will load this 100 records, and if anything updated in this 100 records, like updates or any deleted, okay, so it's going to capture those data, and unique data we going to send to the target table. Again, third day also new records and updated records in the old data we're going to do. So this is the incremental process we're going to approach. Okay, so in Snowflake we can handle the incremental, okay, using streams. Change data capture, we can call it like change data capture. It means if any changes happen in this whole data, it's going to capture those data and it's going to insert it to the target table. So this is usually process. Okay, so this incremental, in which layer we're going to do, we're going to do in the like staging layer. Why we are doing the staging layer? Because of here we have duplicate data and unique data, so it's not it's completely raw data, right? And not tables are denormalized. Okay, not here. Staging layer is like completely normalized. So what is the normalization? So we have different normalization forms. Suppose I have receiving one data, okay, uh, patient id and doctor id, okay, and medicine, okay, department, okay, and so we have some other columns like, okay, what is cost, patient price or medicine details, okay, payments again. So here first take id and take id pen and medicine some give. So department for doctor, doctor name, right? We have also doctor name here, and we also have patient name here. Patient name, patient name here we're going to have. So these are the columns: patient ID, patient name, doctor name, medicine. Okay, doctor name give. Okay, like this patient name give. Okay, maybe. So doctor name, medicine, department give some like JK, and payments give some amount. So this is the denomination table. Okay, here we have patient details and doctor details. Suppose I'm going to insert some more row. Okay, so the same doctor is there for this patient. For this patient, what is going to happen? One second. So again, the department come again here or JK, right? So if the same doctor for the patient ID 2, so here it's going to be same data. This is the same data, right? It's going to repeat everywhere. It's going to store the data and going to take some cost to avoid these. And these are patient details and doctor details are combined here. And medicine is also there and department also. So to avoid this, what we're going to do, separately we're going to create one table. Okay, so we create two tables here. One is like a patient ID, patient name, and what is the so payments of this one. Okay, here we're going to create this one table. So doctor name. So what is the medicine provided? This column going to be common is both the medicine and department. Department no need to be in this patient table. Okay, so name medicine. This is the like denormalization. Denormalization. Okay, so again, medicine and department, right? Okay, so not only this column, we're going to have more columns for the medicine. Separately, we're going to create one more table, and for department, we're going to create one more table. So totally, okay, it's going to be like this. It's not mentioned. Okay, so from this data, how many tables we have? So we have again remove this one. So we're going to create here payments table also, payment tables also. And so we have now see nomination. This is the denomination. This is nomination. Okay, we have patient table and department doctor table, medicine table, department table, payments table. Okay, these are. So this is going to be stored, occupy the lower space and going to be good. Okay, when we do then the like to give and to give the output. So after that we have foreign keys, these are right. So those using those, so we can give the connection. Okay, we can join the tables and we'll get the output. So this is the normalization. So we're going to receive real time the denormalization data. So after that we need to normalize the data. So it will done by the architect or admin or developers we can do. So nowadays what is happening? So developer. So you won't create warehouse in the Snowflake. Okay, it will the warehouse going to created by the admin. But nowadays we need to create some the warehouse. And sometimes we need to do the modeling. So modeling is like star schema and Snowflake schema, and that data modeling also we need to do. Sometimes we need to monitor. It is admin. Yeah, the developer also we need to monitor the data. Sometimes we need to move that data. Okay, dev to test. Okay, and test to prod we need to move the data. So how we going to move our data? Okay. So these are okay. Here, what is happening? Admin having different work, architect having different work, developer, but analyst also having and testing team also. But these nowadays they are asking about everything. So in my training, I'm going to cover developer, okay, even admin and architect, okay, architect, then analyst, okay, and how they going to test. Okay. So everything covering. Okay, so you can apply for the not only developer, you can put in admin. I have also done admin side RBAC concept. Okay, monitoring on the architect side, Snowflake star schema. So analyst side, okay, and testing side. Okay. So every role I'm going to cover in this training. So no worries about that. Okay, these are the like normalization, and here we have layers, right? We have so raw layer, and again um, curator raw layer, curator client instance manager. Okay, so what right here? So raw layer, and again staging layer. Again we have the curator layer. Okay, so these are the standard names when we are talking discussing standard names here. Suppose if you see, okay, a real time. So raw layer is fine, staging fine, curator fine. But in there we going to have different names as per the team members and team lead. Okay, so maybe staging you can call it like intermediate layer or transformation layer, or uh, here curator layer maybe final layer, reporting layer, presentation layer. So that we going to have different names. So these are the layers in the Snowflake. Okay, so and what are the layers? So in DBT we have again staging, raw data, and again intermediate, okay, transformation data, and the final output data is a mark layer. So here sometimes we're going to have also name here. So mark layer also here also we're going to have a mark layer also name. This is the usually uh, these are the layers in the Snowflake. These are the layers in the DBT. So what are the environments? Okay, so we have what are the environments we have? Environments like so development. Okay, we go into work and dev to after dev again we have testing environment. So after that again we have prod environment. Okay, these are the standard. So dev to test and prod. Okay, how we going to move data? So usually without DBT in Snowflake, we're going to connect with the GitHub. Okay, and some actions. They will be going to use Python. Okay, and they're going to load the data. So sorry, we're going to move the data dev to test to production environment. So when we have DBT, so what we do, we will create some environments in the DBT, dev environment, test environment, production environment. Then we connect the GitHub. Then there is a cloud job schedule in the 1 second. Take a chart. So cloud job schedule is there. So when we run this scheduler, okay, some comments there in the DBT. So the data going to move dev to test, test to production. Okay. So this is way of moving the data. So this is also we going to do in the class. Okay, how to move data dev to test production. Okay, and our back concept, everything we will cover. So these are the data. So layers, okay, raw layer, staging layer, creator layer. Then in DBT these layers, so these are the environments, dev, test, production environments are these. Okay. So this is completely about you going to client give one requirement. After that, manager going to discuss with the client. Then he will discuss with the architect. Then architect will tell you approach the manager. Then manager assign to that work to the developer. So with developer, we're going to do the work. After that, in staging the tester, okay, QA team, they're going to test the data. So after that, it going to move to the production. Okay, so there will be any issues, it come back. Okay, this is the data. So this is fine, right? Okay, so what we need to face real time issues, like suppose I have column one, okay, and the column two, and the column three, and the column four I have. These are columns I have. So the project started. Okay, I'm receiving a file from source of having the four columns. So in my table also having the four columns. Table also having the four columns. Four columns. So after some time, okay, the data now the data in we have in the dev environment, test environment, production environment. Currently the source who is providing the data, the client, so the hospital, the instance. So they added one column. So they added client. Okay, client added one column in the data. So I add one column in the file. So now we have four columns right here. Now we're going to have the fifth column, new data. So we're going to receive new data when usually we have tables column. Okay, so now we're going to have in the file five columns. So now table still have only four columns only. Okay, so only table having only like four columns. So what we keep investigate. So if there is data in dev, simply we can use alter, we can add a column. But the data in this testing environment and the final production environment also. Okay, so then what is your approach for this one? Okay, we're going to we have different, right? Okay, how are you going to handle this one? So in that real time, what we're going to do when we receive new data, so we're going to have the meeting and it's going to take like 2 days to fix this one. Okay, so we go with like the final the result going to they will decide to so schema evaluation. So that we're going to do it. Okay, schema evaluation, so how the receive like data, so what it going to be. Okay, so this is when we are with the schema new data added. So this is fine, we're going to receive error data, right? How to handle error data. And you have four different files and different columns in the S3 bucket. But here in Snowflake, you have four different tables. Then how are you going to load those data? Okay, so at a time using copy command or Snowflake, how you going those data? So that error data and those data. So statically, dynamically, static. How can we do? And dynamically, how are you going to do? Dynamically means like we're going to use the what we're going to use the store procedures. Store procedures. Okay, store procedures. We're going to use dynamically. This is static. We can handle that easily. Okay, yeah, everywhere. Okay, even you can find in the YouTube also. So that is dynamically how we going to do. Dynamically, we need to use the store procedures. Okay, that we're going to handle and handling the error data. Suppose if you have null error, it's fine. Data type issue error, it's fine. Okay, single. But you have null errors, data type issues errors, some other you have missing columns, okay, missing data. So how to going to handle that data? How are you going to handle that data? Okay, so that is we going to see everything in the class. Okay, so here the meeting is going to end. Okay, same link, rejoin. Okay, So with same link rejoin. I'm ending the meeting. I will start again. Same link rejoin. Okay, rejoin everyone. We will discuss what is Snowflake and DBT. This is about like team size, like 12 members. Okay, we're going to cover these things, and we're going to do completely project with large data sets, healthcare domain, data migration project. We're migrating data directly to Snowflake. So client will provide different details, okay, different sources. We're going to get data, client, incidents, patient detail, doctor details, okay, and hospitals details. Okay, this is client manager or tech, okay, and star schema approach, stored schema approach. So after that, we need to implement a Snowflake developer. Okay, after doing the work, so analyst what you going to do, and BIT. So they will generate the reports. DB developer, Snowflake developer, everyone going to do. Okay, this is. So next go to, okay. So we have discussed, right? Okay, raw layer, staging layer, created layer. So staging, intermediate, mart layer. This is in the Snowflake. So these are in the DBT. So now here we going to, one second. Next, stay. So we have dev, test, production, environments. These are layers. These are environment. So now we're going to discuss what is Snowflake. So Snowflake is completely like cloud-based data warehouse. Who are the competitors? So Amazon Redshift, BigQuery, those are competitor to the Snowflake. Here, so why many companies using Snowflake? Here we have separate layers. Okay, here we have database storage layer. Then we have compute layer or query processing layer. Sorry, not layer. So again, we have database storage layer and compute layer, and this is storage layer. Okay. And here we have one more layer, cloud services layer. Okay, so this is one advantage. We have separate layers in the data. It means so we have the data going to store in this database storage layer. So the query going to run in this compute layer, and the cloud services layer, it will going to take care by the services like security features. So when we the query is running in this compute layer, it won't affect by the storage. Even you have 2 TB, 5 TB data. So this is one advantage in the Snowflake. So we're going to discuss completely in the classes. So these are subject layers. So we have in the Snowflake. Okay. So next one is scalability. Scalability means like, so when we are receiving large data, large files, and if the query is running slow, so in within a second we can increase the warehouse size. We have small to medium to large. So we going to increase the warehouse size. So that is the scalability we have in the, okay, we can handle the large tables. So large means like billions of rows, 10 billions of data you can handle in the Snowflake. Not only 10 millions, more than that. Okay. So that is scalability. When you need it, you can increase the warehouse size. When you don't need it, you can decrease the warehouse size. Okay. That we can call vertical scaling we have. And clusters. So when you want to go speed, when we are driving car or bike, okay, so we're going to change the gear, right? We're going to change the gear. If you go in first gear, it's going to be some speed, and if you go second gear, it's going to be speed. If you go third gear, more speed, like fourth gear, fifth gear, going to more speed, right? So like that we have clusters here. clusters. So clusters are nothing but uh, like gates. So if you want to quick output, quick if the query is taking longer time to run, and if the data is loading slowly into Snowflake from S3 Snowflake, then you're going to do what you're going to do. We're going to add the clusters and increase the clusters. Adding the clusters, you're going to pick the speed. So this is one advantage in the Snowflake. We can add the clusters, the requirement. So whenever don't need, we're going to be use only one cluster. When you need, we're going to be high clusters. Okay. So 1 to 10 clusters. So now it is updated 1 to 10 clusters. So go stick with 1 to 10 clusters only. Okay. That we will discuss everything. So this is one advantage. And uh, compute layer. These are layers. Okay. This is separate layers. So advantage and scalability advantage, clusters advantage. So SaaS model, it means suppose you're going to book a Rapido Uber, right? If you want to travel one place to another trip, so what you're going to do, you are not paying for that bike and entire that bike cost and everything, petrol and everything. You're going to pay for ride. Right means, so you are suppose in the Dilsunagar, if you want to go to Elbinagar, so there will be 5 kilometers. In that distance, you're going to pay for that distance only. What is the traveling? So 1 point to 1 point. Okay, you are using only the 5 kilometers traveling for that bike you are using. So like pay SaaS model means, this is not SaaS model, sorry, pay as use model. Okay, you are traveling, right? So what you use, you need to pay for that only. So this is one advantage, pay as use model. So what you use, you need to pay for that only. So like suppose you are taking 2 TB from Snowflake. Okay, you are using 1 TB is active data. 1 TB is not, there is no activity. You are taking 2 TB storage. Okay. So 1 TB is active, you have data, and 1 TB is not active. So here you need to pay for only this. Pay for this only. Okay, this only. So this is one advantage in the Snowflake. Okay, pay as use model. Okay. And SaaS model. SaaS nothing but we no need to install anything, no installation. Simply in Chrome just Chrome create account, okay, Snowflake account, and then you can start using in the computer. No need to install anything. But suppose you have in different place, okay, how can you go and you created a Chrome account in your laptop in India. Now you are moving to USA. So then you don't have your laptop. Then how you going to access? Now you have mail ID, right? And if you don't have the mail ID, you have like account identifier. Okay, you have like account identifier about your Snowflake account. So then there you can log in and you can use it. Okay, so I'm creating Snowflake account, and we have 8 to 12 members, right? Okay, so same account we can, it's going to use it by the 8 to 12 numbers. Okay, so here we have for the username and password. Okay, so you get team size. So these people, everyone have same account, using account identifier, they can log in. So using what username we need and password naming. Okay. So if you want to enter username and password, what we need before account identifier we need. Okay. If you have account identifier, wherever you go, you can enter Snowflake account. Okay. So no introduction, no, it is no need to tell anything. So completely everything done by the Snowflake only. Even if you insert data, it will handle by the Snowflake only. Okay. So this is the first process. Okay, this is the advantage also. So main like layers, cluster scalability, warehouse sizes, different warehouse sizes. Okay, so SaaS model, pay as use model, and other features. So concept like zero copy cloning feature is there. So what it going to do, so after loading data, so we need to back up the data. We need to maintain the data consistency. So when we are receiving the files from source, so what are the, sorry, so types of tables? Okay, what are the files, what are the columns in that? So until end of the query layer, we need to maintain same tables and the same columns we need to have, right? Okay, so that is data consistency. So we need to maintain. Suppose in between test, if you anywhere, if you any disaster happen, it will be going to last, right? So for that, for backupping, okay, for if you want, there are multiple users are working, okay, so they need to how they going to access civilian data losses and the same data there are two people need to access. I'm user one is there and user two, they need same table but their approach is different, okay, task for them on the same table. So how they going to do? Here we have zero copy cloning, these we are using for the so backup. So backup is very everywhere is there. Then so what is the special here? Suppose I have a database schema table, so I'm having millions, 1 million rows in this 1 million records are having in this table. So then again, I'm cloning this table using zero copy cloning, table clone table. So this table are also having the same 1 million records. Okay, just copying the data. So what is special here? Okay. So here table this one going to be having like storage and storage cost, right? So this table clone table it's having data but no storage and no storage cost. Okay, so after cloning both are independent, that will be discussed in the classes. Okay, so this is advantage. Okay, even this table having the 1 million records but this, for this table so we don't have storage and storage cost. Okay, we can back up the data even if you drop the this base table, so still you're going to have data in this clone table. Okay, so this is one advantage. And then so time travel. Okay, so what is the time travel? Okay, suppose I'm working today. Okay, think January, February, March. So March I'm working. There is in January I have one patient's details or any insurance claims details. One table is there. In I worked with in January. So insurance January. So insurance table is there. So table. So I could be written and then in February I drop. Okay, I drop it. Okay. Then again March I need again to like again I'm receiving some new updates in the insurance details. So March I need the detail. But you dropped in the February, right? So using time travel, we can go back into time and we can get back this dropped table. So using time travel, we can get back. So this is advantage. Okay, this is one real time scenario. So if you suppose there is a new employee, okay, so he updated the statement. The millions of rows are there but he have not used a where class. Suppose I have 10 rows in a table. Suppose I updated like select where select start from table like update table name set salary equal to 10,000. uh, I given like that, it going to update for every row, right? 10 rows. But okay, update table name set salary equal to 10,000 where id equal to 7, like that we need to give, but he are not given that one. So now it does that happen, right? Everything going to be changed like 10,000. So in that scenario what we going to do, we going to use time travel. So we going to get it back original data. Okay, so this is if anything disorder, anything deleted, so any crash happen, we go using time travel, we can get it. So original data, that is time travel feature. So we can up to 90 days we can recover the data. Still if you want to recover the data, there is like option fail safe. Fail, that is fail safe is for like 7 days. After 90 days totally you can recover the data 97 days. So fail safe we're not going to do in real time, it will done by the we need to contact with the Snowflake team. There will be customer services that will be there. It raise a complaint, then it will go to the Snowflake engineers, and engineers means who are working in the Snowflake company. So they're going to create separate data schema and they're going to record for us. It will take some time and some cost. Depends. Suppose it will be going to clear only 2 hours. So our bad luck it going to be take 3 days also, more than that also. Okay, so that is fail safe option. Okay, we have that is time travel feature. So incremental process, we discussed it, incremental loading, right? And then so we have table types. Usually we know about permanent tables and temporary tables and transient tables. Okay, transient tables. Okay, these are we have, right? Permanent table, temporary tables, transient. But nowadays we have like dynamic tables. Okay, we're going to create in the Snowflake, like metalize views, okay? And iceberg tables. Iceberg tables also we have, right? Iceberg tables. We have dynamic tables and iceberg tables also. So we have it. Okay. So to avoid this incremental, so from source I'm this in the data. So but the client you want, I need immediately result. I need quick result. So what we do real time, we load raw layer, connect with the DBT, then staging, then we do transformation, then it going to curator layer, then again reporting team like that, right? It will take a lot of time. Okay. First we need to S3 to Snowflake, Snowflake to DBT, DBT to again Snowflake, then some layers, then it going to be reporting. It will take process. But here, so what we're going to do using dynamic tables when we are receiving from source to from source to target table in the Snowflake. After that, we are creating dynamic table on that data. So what we need the output result set, that query we will write on that table. So directly that data going to share with the BA team. So the client requirement, I need immediate data. Okay, immediate output. Like that, we're going to do it dynamic. So tables. Okay, instead of incremental process. Okay, and we are using dynamic table nowadays, and we can set it going to refresh automatically limit time 1 minute 5 minutes like that. Okay, so this is advantage, and we're going to create iceberg tables. Okay, so this is also advantage. Then so these are incremental and the process, and we have um, like procedure UDF. We have some system defined and some procedures. Okay, we need to try it. We need to have more strong knowledge on the procedure that I will keep. Okay, if you don't know anything, I will give everything. If you don't know, suppose if you are weak in this specific place, then I will provide the files, syntax, everything, some scenarios. Okay, so this and sorry, store procedure. Store procedure is going to work. Okay, and how it is going to handle error data using the dynamically in that scenario using store procedures. Okay, so it is going to be how we do in real time work, so that I will show it you entire, not only for the developer, not for admin, architect, client, so everything, and who are in the team members, 8 members, 12 members. So who is doing which work, everything I will show in the classes. Okay, and then you're going to get real-time experience. Okay, so this is dynamic table, iceberg tables, UDF, and the store procedures we are going to work. So RBAC concept. Okay, and RBAC and role-based access control. Suppose if any new employee goes to the office, we need to access the database schemas, right? Database schemas. Okay, directly if he run the queries, if he select it won't select. Okay, so we need some privileges on that we need to access. So that going to concept. Okay, we're going to discuss, and we're going to discuss about stages. What is stage? Stage nothing but directly we can't load data into Snowflake. In between we need one thing. Suppose I will give simple example. There is a person living in Hyderabad and B person living in the, okay, so Bangalore. Okay, A can't move to B can't move to A place. So they are stick with these places. Okay, A have mobile phone, he want to give that mobile phone to B. So how he can't give? So in between we have, let's see, he can move to A to B, B to A places. So A positive mobile phone to C, then E positive to C positive mobile to B. So here what is A, C and B? Here A means like CSV file, so directly we can't load into the target table. So that we will see. So in between we have stage. So we will put that file into stage. After that, we will load into the target table. C is like target table. Okay, this is the process. Okay, when you are loading data to Snowflake, in between you need stage. Okay, the stage is like temporary, it will hold the data. So when you are loading any file from local machine to or computer to lap Snowflake, okay, if there is 250 MB that file you can load, but the data is more than 250 MB, then you need to go with the stages. Okay, so stages. So CSV file, put stage, push, put in the state, then again load using copy command and target table. This is a stage. So stages are two types. Internal, in internal we have three stages: user stage, table stage, name internal stage, and stages are second stage is like external stages. So what are the external stages? Like those AWS, Azure, GCP, those are external stages. So this is the process. Okay, so are we going to discuss about? Okay, so not only stages and monitoring and how to create warehouse properly. So simple syntax: create warehouse, warehouse name. It's going to create a warehouse. That is not a proper way to create warehouse in real time. So entire thing and how to create the file formats. Okay, uh, RBAC. Okay, this is one. Okay, everything we're going to cover. So and how to data, how we can share data. Suppose I'm having the Snowflake account, you don't have the Snowflake account. Then how can I share this data with you? And I have Snowflake account, other person having the Snowflake account. Okay, so how I going to share the data? Then I have Snowflake account and I'm going to put in the marketplace. Okay, there are three ways of sharing the data. So this is okay, fine, everything. And we don't share our personal details to others, right? Suppose patient ID name, okay, but is what is his medicine and doctor, okay. So what is his fee details and everything, personal detail we don't share with others, right? So suppose your Aadhaar card details or PII, SSN, and if any USA data is there, okay, we're going to handle the USA data, right? So social security number. So you don't need to share this, right? Okay. So for that we have masking policies, data masking policies, the Snowflake. Okay. So we're going to discuss, okay, how to share data securely. How to share data securely, data masking policy. There is like a row policy. So suppose I have three departments: A department, B department, C department. So one, there are three person, there are belongs to each one, each department, like A1, B2, C3. So when we A person, if the query is the on the table, he need to see only A department details only, he no need to see departments of B and C. Okay, so like that we need to set. Okay, so column level security policy and row level security policy. So we're going to discuss, okay, everything advanced level. Okay, not only develop, everything advanced level. So these we're going to discuss. Okay, so for every batch I'm going to add some new content. Okay, everything from start to end. For this batch I'm going to add Snowflake snow convert. Snow convert I'm going to add in this batch. Okay, this is one feature. Then IBM they are using. Okay, IBM they are using the snow convert. Okay, so what is snow convert? In Oracle we have some DDL and some script, right? So it directly if you copy and paste, it won't work in Snowflake. Okay, so we need to convert. Okay, it's going to convert. This is I'm going to add for the in this batch new concept. Okay, so and dynamic tables also we going to implement. So these are some topics regarding how we move the data stage. Okay, I will show you the syllabus, then you will get one idea. Okay, I will show you. Okay, so project flow. Okay, so you're going to get it project flow and DBT. Some first we go with theory. If you know the theory, what are the micro partitions, how the data going to store in the Snowflake. Okay, it's going to one second. So how the data going to store in the Snowflake and RBAC modeling concept. Then the stages copy command. Okay, Snowpipe. If you are listening live data. Okay, so live data how you going to handle. Okay, and error data handling, backup. What is happening behind to the micro partition. So time travel. How many methods? Table types. Types of loads. So streams incremental task. There are we have grandparent child. How going to run essay types? Slowly change dimension to access the historical data. We're going to use the essay type 2. And views. Views are like standard view, metless view, secure view, and secure metless view. Okay, these are giants. What is left giant, right giant? Okay, and how we going to get output. Okay, UDF, stored procedures, dynamic data masking policy, data sharing, and we're going to use so how you going sharing, and what is the pricing, and what is the billing. So resource monitor, these are doing, but I will include resource monitor, Snowflake cache, how the code is going to work. So tagging, you don't need, but I will teach. Okay, means in future you're going to need if you have more experience, more than 5 years or 10 years. Okay, a partner connect means we're going to connect the DBT. Pagination also new one. Okay, but we different skills we need, Python and those things. And what is the storage metrics? Performance to this is very important, and this is complete our data. Okay, we're going to work with these data, these files. Okay, so and completely. So this is Snowflake. Okay, now we move to the DBT. So we move quick. Okay, so one second. What is DBT here? Okay, so am I clear, right, for the concept? You are getting my uh, voice and what I'm teaching you. It is clear for you. So it's only intro, right? Okay. So what is DBT? So here we have ETL tools, right? ETL tools and ELT tools. So ETL means first they will extract the data from different sources, then they will transform, then they will load the data. Okay. So ELT, first they will extract the data, again they will load the data, then transformation. So which approach we are planning? We are planning ELT. So what is DBT is ELT tool we are using for the transformations. So we can do transformation in Snowflake. In Snowflake, we can do it right. Transformation. We can perform T. Why then? Why DBT? So why DBT means we can perform better. Okay, and we have in DBT lineage graph. So documentation, and version control. So version control. Okay. So these are special in the DB. These are we don't have in this Snowflake the lineage graph means. So what is source and what is the target? When you are receiving the data, you are creating one model in the DBT where it comes from. Okay. So you're going to have in the completely end-to-end lineage graph. Okay, this is an DBT. Okay, so even they will ask why they will ask. Okay, reusable codes we can use it. Reusable. So reusable codes, modularity. So procedures we have, right? Those are reusable. We have modularity. So you need to tell this lineage graph documentation version control. Simple example I am giving. So I have a table and the B table and C table in a Snowflake. Okay, I have A to B giant condition and I have B to C giant condition. In Snowflake, now the task is like you need to join these three tables. Three tables you need to join these three tables. So now you already joined A to B table and B to C table. Now you want to join these three tables. You need to write entire code again. You need to write A to B and B to C. You can't use this A to B code and B to C code. Okay, you can't use. So, but in DBT, what you will do if you want to join three? So you go with you have a name like D here, and here you have E. Now you won't return any code. Simply just you give a name. You going to join D to E. So this is advantage in the DBT, so that you can't do this topic. Like reusability and so macros. We have macros. Macros are like works like formulas. We're going to create macros in the macros folder, so that you're going to uh, use in the model. So what is the model? It is a SQL code only. So here I will open the DBT syllabus, then you will get one idea. So first, what we're going to discuss with models. So we have staging models, interval models, and MART models. So test. So DBT, Snowflake. Okay. So Snowflake first models, right? So models are staging, okay, again same intermediate models and then marked models or core models. Okay, we have these models. Okay, again test after building the model we need to do the test. So in Snowflake, not enforce for the constraints. We have constraints, right? Okay, unique, not null for those different constraints. We have Snowflake. If you give an even primary key for a table, if you insert again same data, it's going to accept, it's going to load duplicate data. So because of it is a data warehouse, it need to accept the every data. Okay, so we Snowflake not enforce all constraints. Snowflake only enforce the only, so not null. This is officially, so as of experience, I'm telling default also it will enforce. Okay, enforce. So here what we're going to do, you like there are the singular test and generic test. Here we're going to do unique test and test, unique test and not null test and accepted values test. So what is these accepted values test? Okay, values. Here we're going to show the packages. Okay, these are test, unique, not null, acceptance. Okay, so when I'm doing test, I have 1 2 3 in the table. These values only need to accept this table. Okay, so if any 11 value is there, it going to fail the test. It going to throw the test fail. It going to show the test fail. If you any 11 value enter, okay, it the column should be have only these values. If the column having any 15 20, it going to the test is failed. Okay, so this is fine. When you have 1 to 10, it's going to run the success. But suppose you have not only one, you need to write up to 100 dishes are there. So now you create this in the test. Okay, so if you run the test, it's going to fail. The everything, the syntax, everything fine. So what you need to, so again in that time you need to go to DBT utilities. There is the DBT packages. Okay, this is advantage in the DBT. So packages already, there is some written code. You need to copy that packages, come to DBT. Again you need to paste it. You need to using DBT tips command. Okay, so you need to install the packages. Then if you run on this one, so 1 to 10 it will take. But if you 1 to 10, you need to install the packages. So those we going to do DBT tips. Okay, so these are the test. So next concept is like, where is it? So metalizations. Okay, metalization like even weave and table and incremental and FML. So you have these metalizations. We know about pivot table. Incremental means even we can handle so incremental data in these metalizations. Okay, so incremental data we can handle in the DBT, and FML is it won't create any object in the Snowflake. To save the cost, we're going to use the FML. So next, what we have next, seeds. So we have ELT, right? It going to extract and load data into the warehouse. So here people knows it going to create table, but what type of table it going to create? It going to create only transient table, not a permanent table in the Snowflake. Okay, so when data in the Snowflake, then only we will connect with DBT. There is no data in the Snowflake, we don't connect with DBT. There is no use. So the how the DBT going to work? So when we have data in the warehouse, then the DBT enters. We need to connect the DBT. Okay, without data, we don't connect the DBT. Okay, and we can't create direct tables in the DBT. Okay, so see, we can't create and we can't insert directly. Okay, that limitations are there, that we'll see. So seeds like CSV files, okay, we can convert to permanent tables. Okay, when we table, it's going to be transient table, but when we use seeds, it's going to create a permanent table in the Snowflake. Okay, so we need to know what is behind is happening, not only the syntax on this one. So cloud feature, Java should do like that. Jinja also we are using Jinja syntax. So macros like work like farmer snapshots to access the historical data. So in Snowflake, what we're going to use is type 2 we're going to do using Snowflake. So in Snowflake, is type 2. Slowly change the dimension. But in DBT snapshots to access the historic. I want to access last 5 years of data. So I do bank transaction every day using Google Pay, Phone Pay, right? So when I need some other details, okay, 5 years of transaction I want to check my everything. Okay, my what is the financial status. So in that time we need to access the historical data, right? So that we implemented snapshots, okay, to access. So again, hooks concept, when we run the model, any model, what is happening like before and what is happening after model running, what is the effect, okay? So active, inactive, those analysis, like it is a folder. So to analyze the data we're going to use packages. So when we something is not working in dbt, we're going to increase the packages, okay? And everything this is fine, okay, and this is important, CI/CD, okay, and continuous integration, continuous deployment, okay, how you move data dev to, how to connect with the github, then move data dev to test to prod. So that we're going to discuss entire, okay. So this is dbt, okay. So anything in there. So in AWS, some services related to the data loading, and Azure bulk storage, SQL. In between, I'm teaching giants, okay, views, okay, everything going to cover, okay. I don't miss anything. I will teach end to end, okay. So not only developer, so developer, okay, and admin, okay, okay, and architect, analyst, okay. So what, which person, and how to talk with the client, to talk to him, okay? So then manager, okay. So we're going to discuss on what is a Jira ticket, how to raise a ticket, how you going to get the work, Jira ticket, okay. So there's a team, how you going to behave, everything, how to talk with it, okay. So not only I mean, if you put your resume, put with developing, I work good 5 years like developer, in between the 1 year about admin, and okay. So everything I will cover, so no worries, into it I will teach, okay. So as of now, anybody having doubts regarding this session? So Koteshwar Rao, Shiva, Sridhar, Ishwant Reddy. So the concept is clear, right? Okay, this is only intro class. If you don't understand, so no worries. I will teach anything based to advanced only. Okay. So
Where ADF comes.
yeah, same. From source system to, from S2 to Snowflake, we are loading data, right? So like that only, from source they will, we have data and ADF bulb storage, then we will load into the Snowflake. So there, I told, right, here also it come the process. So this is the process, right? One second. This is the flow, right? Here, this is ADF comes here. Okay, here we can use maybe both. Sometimes it depends on ADF. Here comes when you have data.
Okay.
Yeah,
Okay, you're going to cover that, right?
yeah. Bulb storage I'm going to cover. So that most of them we don't use AWS. So in between I will show that also ADF. That but AWS is easy. ADF is a bit tough. We need to give a lot of connection setup. Okay, so
Okay. So
clear.
how the jobs will be scheduled and those.
Yeah, that will have to teach that environments, right? I will teach that also. Everything. If you need anything extra, I will also include everything. So nothing, I won't miss anything. That's why. So you won't get anywhere in Udemy or in YouTube. Everything is unique and different, complete real time. Yeah, you can go with it. Job scheduling also I will include. No worries. Okay. I will give you everything from us. Even data modeling concept, star schema, Snowflake schema, how to implementation. Okay, so we will start with, okay, intro and RBAC policies and star schema data modeling. So what is the data? How we will set up with Snowflake schema. Then we will go with final star schema. Okay. What is the requirement? We will follow the business logics here. So simple syllabus is not here. So more than syllabus we going to get everything. So so this is any doubt? As of still, Sridhar, Yashwant, Koteshwara. Clear, right? I mean, clear content and subject clear, right? We can
Yes,
talk.
yes.
Okay, we can talk. So